Hello, good day viewers, you're welcome to Chemistry Hangout. I want to chemically welcome you to this channel. If you are watching this channel for the very first time, I will urge you to click on the subscribe button and click the notification bell so that when I upload any video, you are going to be notified. This is one of the best channels as far as chemistry content is concerned. Our aim is to make you grow in chemistry. Our aim is to let you understand chemistry as a subject, understand some difficult concepts in chemistry so that you can be better as far as chemistry is concerned. And we will not stop doing our best on this channel. For people that are my subscriber already, they know that Chemistry Hangout is always coming to give nothing but the best, and that's what we are here to do again. So if you are new to this channel, kindly click on the subscribe button and click the notification bell so that you will be kept abreast when I upload any video. For my subscribers, I want to say thank you for your messages, thank you for your prayers, thank you for your comments. I really appreciate them. I really appreciate them. Thank you so very much. For my students that did, a lot of students that did, the chemistry practical Waec 2023, a lot of students did not actually do alternative A. Some people were given alternative B, right? Okay, so some people did alternative A, and I want to wish them success. I believe with what we have actually given to them on this channel, they should do well. So I want to wish them success in advance. And for people that are doing alternative B, I have promised in one of my videos that I'm going to be, dishing out 1 or 2 content, okay, so that I can guide them for the alternative B, and that is what I am doing. And very important, let me quickly say thank you to Mr. Sylvester. He's one of the person that sponsored this video. Sometimes as private entities too, we need help, yes, because sometimes you have to pay for the laboratory we are using, you have to buy reagents and all stuff like that. So Mr. Sylvester has been helping out and is one of the sponsors of this very particular video. So I want to say thank you very much, sir. God bless you. I really appreciate your kind gesture. And for some other people too that have been supporting us financially with prayers, I want to say thank you too. God bless you. So for students that are doing alternative B, I want to try as much as possible to to explain in such a way that when you see the question on that day, you should know what to do. The people that did alternative A, I think I've done that analysis in my video. It has opened our eyes, even as content creators, chemistry teachers, and a whole lot of things. And so that's the reason why for today's practical, I'm going to explain a lot of things. I'm still going to show you some dynamics where the question can actually come from, so that when you see it, you would be able to answer it. So welcome once again to Chemistry Hangout. So if you are doing alternative B, I want you to sit down, listen attentively. And even if you have done alternative A, of course, there are a lot of things you can get from this video, okay? So listen to it, will serve you for reference purpose, and it makes you better in chemistry. So welcome. So what do I have today? Let's see the predicted question for alternative B. The predicted question for alternative B. I said A is a solution of 1.54 gram per 500 centimeter cube of HCl. B is a solution of sodium hydroxide of unknown concentration. Put A into the burette and titrate with 20.0 centimeter cube or 25.0 centimeter cube of B using methyl orange as the indicator. Record the volume of the pipette, tabulate your readings, and calculate the average volume of acid used. So very quickly, we are going to be doing that. I have filled the burette already, okay, so that we have to be very fast because we are paying for time, in this place that we are. So we need to be very fast. So I'll fill the burette, very important now. So what do I need to do? This is my conical flask. This is my conical flask. Then what again? I have my indicator. So this is my base. You'll be giving all this in your centers. And the reason why I do all this thing practically, for you to see it. Of course, I can always analyze it using oral. Yes, I can analyze orally. But sometimes showing us the practical and how it is being done is very important to boost our confidence. So this is the base. So I will pipette the base. So very important. Okay, you can see that's the base. Pipetting the base into the conical flask. Okay. So let's have 2 drops of methyl orange here. You can see 1 and 2. Okay, so let's start our titration. You have to be careful. Gently now. When you observe the color is about to change, then you have to apply the drop gently. Can you see that one? Okay, let me adjust this. Can you see? Can you see the color change now? So let's read this. Let me adjust this up. I think the volume is a bit much. Let me adjust this. Okay, I have 24.00. So let me prepare my table. Oh, sorry. Put it here. Okay, so let's have our table now. Let me bring this down. Then I have my burette readings. Okay, so I will have rough. I'll be doing 3. One will be for rough. I'll have second. Because of time, you can as well do 4 in your centers. You know, 1 will be for rough. Then you have 3. You have first, second, third. But I will just be doing. So we have burette readings. Let me put this up here because let me put this up here. Burette readings in centimeter cube, very important to your unit. Okay, so I will have my final readings. Okay, then I will have my initial readings. Okay, then I will have this. Don't forget, we refill the burette to 0.00 before we started. So I have refilled that, because of time. So it's refilled to 0.00. So this will be like this. Then the final readings, I said that. Maybe 24.00. Okay, so for my initial readings is 0.00. I would love to refill because the reason why I would like to refill is because you can see this title value is a bit much. Okay, and you have the volume of the burette there was 50. So if I start from here, I'll be having around 48 or 49, but to avoid any issues, I had to refill. So I'll be refilling. That's the reason why I have this. So very important, we have to write our indicator. State your indicator. I said it is methyl orange as instructed in the question. Okay, then I have my volume of pipette. Because you have 20 centimeter cube pipette, you have 25 centimeter cube pipette. So the one we are using is 25 centimeter cube. I hope this is clear. So here I have 24.00. So let me quickly refill. This is my HCl. That's my funnel. Let me quickly refill. Okay. Okay. Very important, you must remove your funnel before you start titrating. So let me pull this away. So let me pull this away. Then I'll pipette again, very important. Okay. So this is the second one. Okay. We'll go the second time. We are doing all this practically. I love doing them practically to boost our confidence as students. 1, 2. I'm using 2 drops. Okay, so I start titrating again. Gently, because I'm feeling like I'm seeing something like is going to change soon. Can you see that now? You can see. So let's read this. 20. It is up to 24 now. It's 23.80. 23.80. 23.80. Okay, so let me quickly refill again. Let me refill again from here. So that will be the last one. You can have first, second, third in your centers. Okay, there's no problem about that. It's going to be correct, so you don't have any issue with that. Okay, don't forget to remove your funnel, very important. So I'll throw this away. And I'll swirl my flax. Then I go again by cutting this. I have to let it, very, very important, you must avoid bubbles. Avoid bubbles. That's why I had to stop and I had to pipette again. Okay. Okay. So let's see what we're going to have again. Okay, so let's have our 2 drops again. 1, 2. So start again. So I can run it as fast as possible because I already know my average. So because of time, you are time constrained on that day, so I can now go gently now so that I can get an accurate end point. Okay, you drop now. About to change. Can you see that now? Can you see it? So let me read this again and adjust it up to where. Okay. So 3. Okay, 0.9. Okay, I'm seeing 8 again. Okay, 23.80 again. Fine. I love this. So 23.80 again. So from here, we can now have the volume of acid used. Okay, so we'll do our subtraction. This will be this, this will be this, okay, this will be this. I hope this is clear. Very important. Your indicator, very important. Your volume of pipette recorded. Please, your units, very important. This unit, very important. Please don't forget it. Units are very important. It carries mark. Okay, so having checked our table, we are okay with this. Then we move on to calculate what the average volume of acid used. So from there, let me partition this. Then I can have the average volume of acid used. So the average volume of acid used, I'm taking this 2, then I'll divide by 2. So that will be 23.80 plus 23.80 divided by 2. So that's still giving me, this will give me 23.80 centimeter cube. So that's my what? That's my VA or my titration value. Anyhow, so 23.80 centimeter cube. Very important. From your result and information, calculate the. Now, from this we have done this, tabulate the readings and calculate the average volume of acid used. So this is the average volume of acid used, which is serving as my what? As my VA. So let me put this here so that it will not obstruct your view, so that you'll be able to see my calculation very well. Okay, I hope this is okay like this. Okay, so from there, now let's move. Concentration of A in mole per dm. I've told you when you are doing any exam, okay, read the question very well to understand the question before you start solving. Very, very important. So let's read the question again. A is a solution of 1.54 gram per 500 centimeter cube of HCl. Now look at the question. They ask us to calculate concentration of A in mole per dm cube. Per dm cube means 1 dm cube, which is the same thing as 1000 centimeter cube. But here in the question, you have 1.54 per 500 centimeter cube of what? Of HCl. So what do? I need to convert this first to 1000. Okay, I need to convert this very particular 1.54 to 1000, which is the standard measurement. Then I can now look for the concentration of A in mole per DMQ. So what do? Because if you remember, if you have been following my channel for some time now, I've told you this formula is important. First of all, use this formula in your titration. The first thing is mole is equal to mass over molar mass. Always remember this formula. If this formula is not compatible or is not suitable, then you can now look for other titration formula that can be used. So I'm asked to calculate mole per DMQ. So mole per DMQ. Do I have the mass? Yes, but the mass is in 500, not in 1000. So I want to convert to 500 or to 1000. Then the molar mass. Can I calculate the molar mass of HCl? Yes, because they are giving me the atomic masses, so I can use this formula. But before I use it, I have to convert this to 1000. Very important. So I'll just say 1.54 in what is in 500 centimeter cube. So 1000 centimeter cube, which is same thing as 1 DMQ, is what is this, is X. So my X will be 1.54 times 1000 over 500. Then we can use a calculator for that. I have 1.54 times 1000 divide 500. That's 3.08. So that will be 3.08. That will be now gram per DMQ. You get that now? So this one, you can see this one is in gram per 500, but this one is in gram per DMQ. You can see now I cannot calculate what concentration of A in mole per DMQ. How do I do that? Now question 1 now. Concentration of A in mole per DMQ. Okay? So I can have my mole, which will be in mole per DMQ, is equal to mass, okay, which will be in gram per DMQ, over my molar mass, which will be in gram per mole. I hope this is clear. So from there, please, any value that you are going to be inserting in this formula, you must make sure that you get it. Because I don't have my molar mass, so I need to calculate that first before I'm now going to use this formula. So molar mass of HCl. So they are giving us hydrogen here. That will be 1 plus chlorine 35.5. That will be what? 36.5 gram per mole. Can you see that? Well spelled out. The unit is very important. So I can now come and say, okay, my mole, which is in mole per DMQ, will be equal to, what is my mass now? My mass now, you can see, I've written this as 3.08 gram per DMQ, 08 over 36.5 gram per mole. So my mole, which will now be in mole per DMQ, will be what? 3.08 divide 36.5. That's giving me 0.084. 0.084. So I have 0.084 mole per DMQ. I hope this is clear. Very clear. So number 2, concentration of B in mole per DMQ. Let's go to B. They said B is a solution of NaOH of unknown concentration. They did not give us the mass. They did not give us anything about NaOH. Meaning I cannot even use this because I don't have the mass. Okay, I don't have the mole. I can only calculate the molar mass. So that means I cannot use this. So which one will I use? Go to our titration formula. I'll be 2 CAVA over CBVB equals NA over NB. Let me give the equation. So I might be giving the equation, very important. So the equation will be this. Since it is HCl and sodium hydroxide, then we have NaCl plus H2O. So this will be okay. So very important. So this is the equation of reaction balance. So what is our concentration of acid? Given already 0.084 times what is the volume of our acid? That's our titer value, 23.80 over what is CB? That's what we are looking for, times volume 25 equals to moles of acid. Look at acid 1 to 1 because the equation is balanced. So we have 1/1. So from there, we cross multiply. We are going to have Cb to be equal to 0.084 times 23.80 times 1 over 25 times 1. So our Cb is going to be what? Let's see again. 0.084 times 23.80 divided by 25. That's giving us 0.080, approximately 0.080. 0.080. Because of my calculator here, I have 0.0799. So that's why I'm approximating to 3 significant figures. 0.080 mole per dm cube. You can see all these things are well sorted. They are simple. Just get the question, understand the question. The third one says concentration of B. Look at that in gram per dm cube. Concentration of B in gram per dm cube. I know that my mole is equal to mass over molar mass. Can you see? This formula is coming in place now. What do we need to calculate now? We need to get the mass. Okay? We have gotten the mole already. We can calculate the molar mass of sodium hydroxide. So first of all, calculate molar mass of sodium hydroxide first. Molar mass of sodium hydroxide. That will be 23 as given to us here plus 16 plus 1. That will be 40 grams per mole. Can you see that? So we are calculating mass now, so we can cross multiply. Here you get. So mass will now be will be mole times molar mass. So our mass is going to be, what is the mole? 0.080 times, what is the molar mass? 40. So our mass is going to be, let's see that now, 0.080 times 40. That's giving us 3.2 gram per dm. Can you see that? Well sorted. I hope you are following. Just read the question and follow suit. That's just it. Read the question and follow suit. So the next one, they said the amount of moles of acid in the average titer. Please take note of this. Sometimes they'll say amount of moles, sometimes they'll say number of moles. Anyone they are using, they know we are still referring to the same thing. Okay? So you can say amount in moles, they can say number of moles, anyone. So amount of moles, how do we calculate our amount of moles? That's N. N is always CV. What is the meaning of C? C is the concentration, V is the volume. Can you see that? So amount of moles, I'm going to number 4 now. So amount, I'm just stating the formula so that you understand how I got it. So amount of moles of acid in the average titer. Okay? So that will be N is equal to CV. Okay? So our N will be concentration of amount of moles of acid. So what is the concentration of acid? Very important. Have you gotten it? Concentration of acid. That's our Ca. Where is it? Where is it? Where is it? Okay. Concentration of acid. Look at the question. Please read the question very well. Amount of moles of acid in the average titer. And I told you for you to calculate the amount of moles or number of moles, you use the formula N equals to CV. Do you get that now? So the concentration of the acid now, that's what? 0.084. So I'll bring it here, 0.084 times, what is the volume of the acid? We have gotten that already, 23.80. 23.80. Okay? So what do? I'll now divide by what? By 1,000. Why am I dividing by 1,000? You need to know. You know, 0.084 is in mole per dm cube. Can you see? Mole per dm cube. But 23.80 is in what? Is in centimeter cube. Can you see that? So we are converting. We should know that 1,000 centimeter cube is what is 1 dm cube. So I'm converting to dm cube. That's what I'm dividing. So the normal formula, which means if this one is in dm cube, I will not be putting 1,000 again. So what you know, some people used to get it confused. They thought the formula is CV over 1,000. No, it is because of the conversion rate. That's the reason why I'm dividing by 1,000. So if this one is in dm cube, then I will not need to put 1,000. But it's in centimeter cube, which is the normal way we do our titration. So I have to divide by 1,000. So what are we going to have? Amount of moles. Let's see. So we are going to have 0.084, okay, times 23.80, sorry, 0.084 times 23.80 divide 1000. That's giving us 0. That'll give us 0.00. Okay, 19. Let me just say 1999. That's what I have here. So let me just say 19992 moles. Okay, or I can say 0.002 moles. I can live in 3 significant figures. So I can have like this. I can have 0.002. Okay, or I can have 0.0020. Anyhow you want it, but you can live like this. You can still have 0.002. You are still saying the same thing approximately. Okay, so from there again, the 5th question is saying the amount of moles of sodium hydroxide. Can you see that? Amount of moles of sodium hydroxide in the volume of B pipetted. So we are still looking for amount of moles. So we are still using the same thing, which is this, N equals to CV. Okay, so amount of moles of NaOH that we pipetted. So we are still using N is equal to CV. Can you see that? So our N is, what's the concentration of the base? The concentration of the base we have gotten is what? 0.080. 0.080. Okay? Times, what is the volume of the base? Don't forget 25. Okay? 25. Are we going to divide by 1000? Yes, because this one is also in centimeter cube. So I'll say divide by 1000. So what do we have? So we are going to have N equals to 0.080 times 25. That's giving us 2 divide 1000. So that's giving us 0.00 have 2 moles. Can you see that now? Very correct. Can you see that? So 0.002 moles. So the next one, which is the last question, the number of moles of hydrogen ion in 1 gm cube of the solution. The number of moles of hydrogen ion. So they will give you something like this. Na, that's Avogadro's constant. If you are asked this question, they must give you this value. It's a constant value. If they are asking you this question, the number of moles of hydrogen ion, so they will give you this constant value, which is Avogadro's number. So what do I do? I'll say they said the number of moles of hydrogen ion. Which of the solutions will produce hydrogen ion? Definitely to be the acid. So, and we have the dissociation reaction to be HCl is going to dissociate to give us H plus and Cl minus. Guys, that which means that 1 mole of HCl, okay, will give us what? 1 mole of what? Of hydrogen ion. Guys, so what is the 1 mole of hydrogen ion in 1 gm cube of the solution? Please don't get yourself confused. In 1 gm cube of the solution, that's what they are asking. Some people will go and use this value. You will be wrong. Because if you use this value, it means that what you are doing is in 23.80 centimeter cube of the acid. I hope this is clear. Because 1 mole of HCl, I'm using this now. I'm using this, which is 0.0084. Why am I using this? Because the question said in 1 gm cube of the solution. So I am not going to use, if the question has said in 23.80 of the solution, I would have used this value. Okay, so get it. In 1 gm cube of the solution. You can see this is 0.084 mole per gm cube. That's what I'm using that. So 1 mole of HCl is giving us 0.084, okay, moles. So if it's 0.084, 1 mole of this gives 1 mole of this. Definitely 0.084 mole of this will give 0.084 moles of hydrogen ion. It's clear. Because 1 of this gives 1 of this, meaning 0.084 of this will give 0.084 of this. And we know that 1 mole is 6.02 times 10 raised to power 23 ions. Okay? So 0.084 we give what? We give X. I hope this is clear. So from there, let me move here. Let me finish up here. So this times this will give me X, and I'm going to have 6.02 times 10 raised to power 23 times 0.084. So let's multiply 0.084 times 6.02 That's giving me 0.5056. So let me just say 0.506 times 10 raised to power what? 23 joules. Can you see that? So what does that? That's the question. So if you are given the question like this, in fact in some questions they might not even give you this. They just tell you to calculate amount of moles of this, amount of moles. So but you know, if that's to calculate concentration of a mole per dmq, amount of moles, you know what to do. So I just have to do this so that you can have a lot of it to prepare for. Now this comes to my mind, and let me quickly do something on it. I'll just explain so that you know what to do. What if the question comes like this? Let me rub off this. And let me just do. What if the question comes like this? That A is a solution containing 3.2 gram of HX. You can see, instead of them to put the HCl, they are now putting X. Okay? They will now tell you B contains 3.2 gram, okay, per dmq of sodium hydroxide. So I'll just explain what to do in the video. You can drop, your solution in the comment box section so that just explain. The question can come like this. You can see they have omitted the X instead of the chlorine to be there, which means if they omit the X, they must tell you to look for what X is. And how will they start? They'll tell you to get the concentration of this in mole per dmq. If they ask you to get the concentration of this in mole per dmq, definitely you are going to be using this formula. If you use this formula, because this is the mass, okay? But you cannot calculate the molar mass because it's HX. You can't calculate the molar mass. You can't do something like this. You can't do something like this. You see molar mass of HCl. Because Cl now is unknown. So meaning we are going to go with this formula. So if you get this formula now, if you go with this formula, using all the parameters, because at the end of the day, 3.2, we are still going to convert it, divide 40. So we are still going to get our CB. You can see, it's just like that. So at the end of the day, if we slot in all this, we are going to get our concentration of acid. Okay? We are going to let me just show you so that you understand. If it comes like this, then if I want to get the concentration of this one in mole per dmq, I'll just still use this formula. CbVb equals to Na over Nb. Can you see that? So Ca, that's what I'm looking for, times Va, we have it already, 23.80 over concentration of base. Since they gave you this, you can divide it by 40. Mole is equal to mass over molar mass. So you divide it by 40 to get this. So at the end of the day, it will just be 3.2 divided 40. You can see to give you 0.08, which is our CB normally. So it will give you 0.08. So this one will be 0.08. How do I get 0.08? They are giving me 3.2 of this. If I do 23 plus 16 plus 1, it will give me 40. You get that? So times VB is 25. Okay? Our moles of acid. So they will now give you the equation like this. They will give you the equation like this. HX, since X is missing, plus NaOH to give them NaX, you can see, plus H2O. That's how the equation will now come, because I'm looking for X. So, but one is still, the mole ratio is still 1 to 1. So at the end of the day, we still have to do this. You get that? So from here, our Ca is now going to be 0.08 times 25 times 1 over 23.80. So let's see. I'm just showing you, the question can come in different, but still we are still saying the same thing. So times, we just want to see if you really understand what titration is all about. 23.80. You can see I'm still getting 0.084. You can see it's still bringing me back to this. That's it. So they are just twisting the question. 0.084 mole per dmq. Can you see? Still bringing me back to this. So at the end of the day, they'll not be saying you should look for maybe the atomic mass of X. So I can now say, okay, since I've gotten this one, I can now say my mole is equal to mass over molar mass. Okay? Very important. So where is the mass now? I have the mass already. I see. Where is the mole now? I have the mole already. So I will have to make molar mass the subject. So from there, my molar mass is now going to be 3.2, which is the mass, over what is the mole? 0.084. So let's see. 3.2 divide 0.084. 3.84. I'm just citing all this example. Or let me say 3.08 so that it will not be the same with this. Let me just say 3.08 gram. That's how the question came. So my mass will now be 3.08 divide, so 3.08 divide 0.084. So I'm going to be having around 36.67. So let me just say 36.7 gram per mole. Can you see that now? 36.7 gram per mole. So after that, what do I do? Then I can get my HX now. Can you see? I've gotten the molar mass of HS, which is 36.7. Can you see? So this one is 1 plus X, can you see, is equal to what? 36.7. So I will have X equal to 36.7 minus 1. So my X will be what? 36.7 minus 1. So that's giving me 35.7. Can you see? So which atomic mass is closer to 35.7? That's what? That's chlorine, which is 85.5. So that is that. So the person can come this way. You can see, it's just like they want to test, do you really understand how titration works? Can you really work your way through titration? So the question can come in the first way I predicted, the question can come like this. Anyhow it comes, any value they omitted, just understand the formula and you will be able to solve it. So that is just that. So we are trusting God that they should not give us beyond all these things I've actually given. I want to be sure that they should not give us more than this, but that's just what the question will be all about. So that's alternative A, that's alternative B. So you need to sit down, practice and practice and practice and practice, so that at least you have around 2 weeks to to still practice this before the exam. So if you are watching this YouTube channel for the first time, I want to believe you have seen that this is one of the best chemistry YouTube channel you can actually come across here, and I want to believe you want to be part of the Chemistry Hangout family. So you can be part of our family by clicking this subscribe button, and you turn off the notification bell so that when I upload the video, you are going to be kept abreast. For the qualitative analysis too, it's going to be a private video for the qualitative analysis. So if you need the qualitative analysis too, you can as well chat me up. Put my number on the screen so you can as well chat me up. But for the volumetric analysis, we should be having this for the volumetric analysis, and we are trusting God that the predictions is supposed to be close to accurate. So very, very important. I love you guys. I wish you well. I wish you good results. I wish you excellent result. And if you are a teacher, I have said that there has been a video that has been going on for some time now. At least a whole lot of teachers have benefited from it. More than 500 plus teachers has had access to it. And what is the video all about? It's just about how to prepare reagents, how to prepare indicators, how to predict right questions, and it's very wonderful. You need it. I'll put the link in the comments box section so that you can visit some of those. You can have access to some of those videos. You check it. If you think it is what you need, the content is what you need, you can chat me up and I'll tell you what to do as regards that. The reason is because NECO is approaching again. We cannot be running helter-skelter because we want to prepare reagents, or because we don't really actually understand how to interpret what is written in the instruction given to school. Okay, so as teachers, we are aiming at getting better in our area of specialization, and that's why this video is actually made. So it's a video training for teachers. If you are a teacher, you will need it. If you are just teaching, just like teaching chemistry in secondary school, you are going to need it. Even if you are an undergraduate and the course you are studying is a chemistry inclined course, you are still going to need it. So it's a wonderful video. You will like it, I'll tell you. So if you like it, you can private chat me. I'll drop the link to in the comment box section so that you can view some of the things that video is actually like. So I love you guys. We'll be coming up with the qualitative analysis, but you can chat me up if you need the qualitative analysis. Very, very, very important, so that we can be better. So keep practicing, keep practicing. I love you. Thank you so much. Till we meet again on this channel, stay chemically active. Bye.